let's talk about the topic of agent memory. So, agent memory can be broken down into two primary kinds of memory: short term and long term. And then long term can be further broken down into semantic, episodic, and procedural. So, short term, as the name suggests, lives for a short amount of time. It exists in that single thread or that conversation that's ongoing, and it uses a checkpointer to pretty much take a snapshot each time, and it's kind of that context memory that's ongoing, but it's all short lived and it's not passed on to other conversations or um, yeah, other threads in that respect. Whereas long term memory with the three types, they all kind of have their role in the long term memory of the agent. So semantic focuses on facts and preferences, episodic focuses on experiences and outcome, and procedural and rules focuses on rules and instructions. And I like to think of it more around kind of that system prompt. And policy side of things. For long term, it uses a store. So when the conversation ends or is deleted, there's still that long term memory persisting. And to keep things tightly scoped, it usually uses a namespace and key for that piece of information. So jumping into the workbook, we went through and did a bunch of testing using different examples showing that with different users, kind of that thread is kept separate for the short-term memory side of things. That was an interesting one. On top of that, we also started to think about the question of like how and who should be able to write to long-term memory. Should it be that the most long-term memories are approved by the user so that the user knows what is stored, and it kind of also verifies the agent to make sure it's not kind of making up a false memory and storing that. So that kind of policy around what is stored long term and what isn't is very important. And then so we can see that here: procedural memory with review, feedback, model proposes a candidate, and then the human or policy will review that. This is probably very important, especially as you start to take things into production and for organization, who approves what memory is stored and what exists where. So in this example here, we built a unified memory agent, and you can see that discussed here. There's kind of a piece of middleware that functions and reads the store before each model call, so it kind of keeps that memory kind of in the front of the AI's mind, if you could say that, so that the user experiences relevant results based on their preferences and its memory. So you can see that diagram here. Okay, now let's jump into the other cool piece that we touched up on in this workbook, and that was graph enhanced agentic RAG. So previously we'd discussed the idea of RAG using semantic search. So where you get where you have a query, and then that gets a semantic, that gets pretty much a semantic score, and then similar chunks with like higher semantic scores in the vector database are pulled out and then passed into the context, whereas RAG kind of well, in the example we did, it would pass the query, look for connected entities to the query, and then link those up, and then find supporting chunks. So this kind of allows us to ground our truth in in actual examples, not just kind of a meaning and semantic score, and it gives more of a graph, a knowledge graph to work from. So you can see here we've got object, relation, subject, relation, object, section, evidence, and so we can pass queries, break them up. So in this example here, we used a bit of an entity analysis. So if somebody asked about older cats, we'd also would refer to senior cats, and then from there, using senior cats, we could find a relevant subject like this, and then this would give us that information, and so on, and then we would have kind of evidence to support claims based on different queries, and then moving further down, allowing the agent to either choose semantic or graph retrieval. This was an interesting topic because it kind of allowed the agent to decide what to use, either semantic or graph, and depending on the query itself, it would kind of steer which tool was called. So as an example, I think I asked the question, like, so here, if you ask what signs suggest a urinary emergency in a cat with this example, it would probably call the semantic, the dense tool, and then do a kind of a semantic search. But if you had asked the question, what signs suggest a urinary emergency in a cat, and what relationship does this have to age? By just adding that idea of a relationship, it will more likely begin to call the graph searching tool. And here we went ahead and extended that graph search. But all in all, it was a very interesting topic, and thanks for listening.